So when we have a curve given in parametrics or in polars, we should be able to calculate the same kind of things that we calculate in the regular functions that we know in Cartesian coordinates. So if we have, for instance, this curve given, say, in parametrics, and say we have a spiral like this given in polar coordinates. So in each of these cases, we should be able to calculate at any given point what is the slope of the tangent line, so what is the slope of the tangent line, and we should be able to calculate also for instance, say the arc length. We can calculate how long is this curve from here to here. We can calculate how long is this piece of the spiral. And in the case of polar coordinates, we should be also able to calculate the area between two angles. So for instance, between this angle and this angle, we may be interested in knowing what is the area there. So we should be able to calculate then these three things. I mean, the slope of the tangent line, the length, and the area between two angles. Well, to calculate the slope of the tangent line, if the curve is given in parametrics, that is an x that actually depends on the parameter chi, and the y that depends on the parameter chi, we are interested in knowing how much is here the derivative of y respect to x. For that, let's think of the functions in the regular way that we had given, like y in function of x, but now think that this is actually an x that also depends on t. And so if we want to calculate like the regular derivative, that is the derivative of y respect to the variable t, so then we know that in this case the variable f depends on x and depends on t, so it's a composite function. So we should use actually chain rule to do this derivative, and so that will be the derivative of the function respect to x times the derivative of x respect to t by chain rule. And we observe that this derivative here that we have in red, the derivative of f respect to x, this is just f is y, right? So this is just the derivative of y respect to x. That is the derivative that we want to calculate. So we have here this derivative as a part of a product, so we just can solve for it. So just solving for the derivative of y respect to x is going to be equal this divided by this, right? This one comes here dividing. So this derivative is going to be equal to the derivative of y respect to t over the derivative of x respect to t, right? So this divided by this. So then we just have the formula for the derivative. The formula for the derivative of a function given in parametrics will be just the derivative of y, because observe that derivative of y respect to t is just the derivative of y, right? So y have only variable t. So this derivative is just the derivative of y respect to t, just the derivative of y divided the derivative of x. So let's look at this example. In this case, we have this function given. This is the curve that we have to calculate the derivative, and we have to calculate the derivative at this point. If you do a graph of the function, that you can do it by hand with a few points, or you can do it in Sage to have an accurate representation, the curve is going to look like this. And the value of the derivative at 0, so what we are trying to find here is at 0, this is the value at 0. You should check that by your points in the chart of the Sage evaluation. But the point for t equals 0 is this one that I am marking. So what we are asking for is what is the slope of the tangent line here. According with the drawing, we can see already what is this slope should be. But let's calculate it. We know that the derivative of y respect to x, according with the formula that we found before, we have to calculate the derivative of y and divided the derivative of x. So let's calculate these derivatives. The derivative of y, so y is this function here, so the derivative of y is going to be 3 sine of t. And the derivative of x is going to be the derivative of this, which is going to be 1, right? The derivative of t is 1 minus the derivative here, that is going to be 3 cosine t. So this is the derivative, that's it. I mean, this is the derivative that we were looking for. So now, this is the derivative for all t values. So by plugging in different values of t, so we can get the derivative at different points of this function here. In this case, we are asked to calculate the derivative at t equals 0. So we just evaluate this function at t equals 0. I mean, plug in. So we plug in 0 for t. We substitute, and we obtain that this is 3 sine of 0. So this is going to be 0. 0 divided by anything will be 0. So we got that the derivative at this point is 0, which makes sense, right? Because we are obtaining that the slope of this blue line here is 0. I mean, this line looks horizontal, and we are obtaining that the slope of the tangent line is really 0.